Minerals. There used to be a TV commercial that said, "You are what you eat."
You are what you eat, from your head down to your feet. Things like meat and eggs and fish you need to build up muscle tissue.
If that's true, and to some extent it is, are you a mineral? Nearly all our food is salted. And what is salt but the mineral halite? You also wear minerals. You play with and on minerals, and admire the beauty of many minerals. However, a mineral by definition cannot be organic, so despite what you hear on TV, you are not what you eat. What is a mineral? Minerals are everywhere. Scientists have identified more than 4,000 minerals in Earth's crust, although the bulk of the planet is composed by just a few. A mineral possesses the following qualities. It must be solid. It must be crystalline, meaning it has a repeating arrangement of atoms. It must be naturally occurring. It has to be inorganic, and it must have a specific chemical compound. Minerals can be identified by their properties such as hardness, color, luster, which is shininess, and odor. Most common laboratory techniques used in identifying a mineral is X-ray diffraction, or XRD. A technique that involves shining an X-ray light on a sample and observing how the light exiting the sample is bent. XRD is not useful in the field, however. The definition of a mineral is more restricted than you might think at first. For example, glass is made of sand, which is rich in the mineral quartz. But glass is not a mineral because it's not crystalline. Instead, glass has a random assemblage of molecules. So what about steel? Steel is made from mixing different metal minerals like iron, cobalt, chromium, vanadium, molybdenum. But steel is not a mineral because it's made by humans and therefore not naturally occurring. However, almost any rock you pick up is composed of minerals. Here we will explore the qualities of a mineral in more detail. Crystalline solids. Minerals are crystalline solids. A crystal is a solid in which the atoms are arranged in a regular and repeating pattern. Notice that in this figure, the green and purple spheres represent sodium and chlorine. They form a repeating pattern. In this case, they alternate in all directions. Sodium ions, which are the purple spheres, bond with chlorine ions, shown as the green spheres, to make table salt, which is halite. All of the grains of salt that are in a salt shaker have this crystalline structure. Inorganic. Organic substances are the carbon-based compounds made by living creatures and include things like proteins, carbohydrates, oils. Inorganic substances have a structure that is not characteristic of living bodies. Coal is made up of plant and animal remains. Is it a mineral? Coal is classified as a sedimentary rock, but is not a mineral. Naturally occurring. Minerals are made by natural processes. Those occur in or on Earth. A diamond created deep in the Earth's crust is a mineral, but a diamond made in a laboratory by humans is not. Be careful about buying laboratory-made diamonds for jewelry. It may look pretty, but it's not a diamond, and it's technically not even a mineral. Chemical composition. Nearly 98.5% of all of the Earth's crust is made up of only 8 elements: oxygen, silicon, aluminum, iron, calcium, sodium, potassium, and magnesium. And these are the 8 elements that make up most minerals. All minerals have a specific chemical composition. The mineral silver is made up of only silver atoms, and diamond is made up of only carbon atoms. But most minerals are made up of chemical compounds, a combination of 2 or more different types of elements. Each mineral has its own chemical formula. Table salt, also known as halite, is pictured here. It is called sodium chloride, and the symbol for that compound would be NaCl. Quartz is always made up of 2 oxygen atoms, shown here in red, bonded with a silicon atom shown here in gray, and it's represented by the chemical formula SiO2. In nature, things are rarely as simple as they are in the lab, and so it should not come as a surprise that some minerals have a range of chemical compositions. One important example in earth science is opaline, which always has silicon and oxygen as well as some iron and magnesium properties. Some minerals can be identified with a little more than the naked eye. We do this by examining the physical properties of the mineral in question, which include color, which is the color of the mineral, streak, which is the color of the mineral's powder, which is often different than the color of the mineral itself, luster, or shininess, density, which is mass per volume, typically is reported in specific gravity, which is the density relative to water, so it kind of looks at whether it can float or sink. Cleavage, the mineral's tendency to break along the planes of weakness. And fracture, which is the pattern in which the mineral breaks. And finally, hardness, which is a mineral's ability to scratch another mineral and its ability to be scratched by another mineral. Summary. A mineral is inorganic, it's crystalline and a solid. A mineral is formed through natural processes and has a definite chemical composition. Minerals can be identified by their characteristic physical properties such as crystalline structure, hardness, density, breakage, and color.